Moving on to section 4.3 here, we want to talk about how exponential functions graph. So we've looked at exponentials, we've looked at how they work in terms of rules and simplifying and all that stuff, which is technically review from earlier courses, right? But now we want to kind of think about how they would work in functions and what that would look like when you graph them. So I have this function right here, which is f of x is equal to 4 times 2 to the x, and I want to graph it by hand. Now, graphing by hand is kind of interesting because when I say by hand, it doesn't mean you can't use your calculator to help yourself. In particular, what you really want is a table of points, because if you can find a table of points, then you can graph from there. All right, so let's go to my calculator. I'm going to go to y equals. I'm going to clear out my old equation in there, so I don't want that. And now I'm going to go and type in 4 parentheses 2 close parentheses to the x. Now I have this new system, so it puts x so that it's up in the superscript like that, up above the line. If you have the old one, it'll make this little caret symbol, right? Right above that division button. It'll make that symbol, which is called a caret. All right, so there we go. Now I can go to the table, and I don't really want this stuff because look how big those numbers are. But I can get back down to where I have the actual table on the paper, -3, -2, -1, and so on. So I can see -3 goes to 0.5, -2, excuse me, goes to 1, goes to 2, 4, 8, 16, 32. Now you might be wondering to yourself, and while I'm at it, I'm actually going to add in another one, 64. So you might be saying, oh, Lana, how did you do that so fast? Is it just that you're, that good? Well, yes, but there's something else going on here. Right, you'll notice, and we're going to hit on this a little bit more later, but you can see right here that when x is 0, what's the y value? 4. Now, how did that happen? Well, if you put 0 in for x, 2 to the 0, this part right here becomes 1. And 4 times 1, because that's the operation there. I don't put it there, but there's, of course, a times dot there. 4 times 1 makes 4. So that's why that one's 4. And then 4 times 2 to the 1, 2 to the 1 is 2, so 4 times 2 makes 8. And then you'll notice that as I go down, what am I doing? 4 times 2 makes 8, 8 times 2 makes 16, 16 times 2 makes 32, and so on. And it matches the numbers from the calculator, look. 1 goes to 8, 2 goes to 16, and so on. Now, why is it multiplied by 2? This is just a little preemptive strike to what's coming later, and it's because that number in the parentheses there is 2. So 0 goes to 4, and then you double it as you move down. So if you're going to graph that, let me bring up some dots. Hold on. There you go. So there are the dots. And I actually threw in a couple more in there, but you can see 4 goes to 64, 3 goes to 32, and so on. And hopefully you can detect that this is not a line. And we're not in Kansas anymore, right? So this is a curve, an exponential curve. And that's what they graph like. So then you got to connect the dots. So let me add those in. And by the way, the program I use to do this is called Advanced Grapher, in case you're ever interested. So there you go. There's the graph. All right, so now we'll do it again. But this time, ooh, we got 8 times a half. That's got a fraction in it. That's always tricky. All right, so let me go back here. Y equals, I'm going to clear out the old one. 8 parentheses 1 divided by 2, close parentheses, to the x. And again, your calculator might not make that same symbol notation. Mine does. That's just because I've got a newer system on this. Not the newest system, but a newer. All right, then I go to the table. And if you don't see pretty points right there, you can always kind of scroll up and down to get some. But we've got -3 goes to 64, then 32, then 16, then 8, 4, then 2, then 1. And while on the subject, 4 would go to, you might be thinking 0. 64 times a half gets you 32. 32 times a half gets you 16. 16 times a half gets you 8. Notice it's a half every time because that's what your base is, see? And 1 times a half would be Oops. Hold on. There we go. Cool. All right, so now we got to put those dots in here. So let me go grab those. There it is. Now I know it's so quick when I do it, but when you do it by hand, it can be more tedious because you got to sit there and put all the dots down. But such is life. All right, then you just need to connect it up with a curve. There it is. One curve for you. Alrighty then. Now you notice I'm kind of hitting on a couple things, and I wanted you to notice that when I look at this one, when I go from one point to the next point to the next point, I'm cutting it in half. 64 times a half gets you 32. 32 times a half gets 16, and so on. If you look at this one, I go, 1 times 2 makes 2. 2 times 2 makes 4. 4 times 2 makes 8. The reason it's 2 is because that's my base. The reason it's a half is because that's my base. And that's what this box right there says. That when it's an exponential function of the form a times b to the x, that's the way all of our exponential functions are going to look, then the value of the independent variable increases by 1. That means when x goes up by 1 as you move down the table 1, the dependent variable is multiplied by your base. Hold on. There it is. Your base, b. B being the thing that's being raised to that power. See, since a times b to the x, b is the only part that gets raised to a power. So for example, look at this one right here. 2 times 3 to the x. So you'll notice it starts at 2, 0, 2, which it didn't have to for the record. I'll just insert a row right here. If it had been -1, that would have been, oh, not that button, 2/3, believe it or not. Okay, and then the next one would be 2/3 times a third, and so on. So 0 goes to 2, right? When x is 0, y is whatever that number in front is. And then to move down 1, you multiply by 3. 2 times 3 makes 6. And then 6 times 3 makes 18. 18 times 3 makes 54, and so on. Okay? And how did I get the 2/3? Well, if you're going to go backwards, you divide, right? You're going to go forwards, you multiply. All right, let me make a note of that. Hold on one sec. There we go. So to get from 2/3 to 2, you multiply by 3. To get from 2 to 6, you multiply by 3. I mean, and I could keep going for forever, right? To get from 6 to, 6 to 18, you multiply by 3, and so on. And just keeps repeating over and over and over. That's what the base is. The base is the thing that you'd multiply by, and that's what the base multiplier property is saying. It's saying, look, that base, b, is what you multiply by to work your way down the table. Okay? So let's look at some input-output pairs down here. And then we're supposed to find the equations. So I guess I'm going to make a note right here as well. So let me make a note. So if b is the base multiplier, working, it's what you work down the table, and then a is the, well, here, put it this way, 0, comma a is the y-intercept, right? So like this one was 0, 2 because a was 2. See it right there? Or back here on this one, 0, 8, right there, 0, 8 because a was 8. Or on this one, 0, 4 because a is 4. So if we look at this one, because we're supposed to find some equations here. Okay, so we need to figure out what we can multiply by to get from 4 to something, and then get from that something to 36. So, I mean, you can just try different stuff. You say, okay, 4 times 1. Let's try that. 4 times 1 gets you 4. Well, that's no good. 4 times 2. 4 times 2 is 8. 8 times 2 is not 36. So that's no good. Let's try 3. 4 times 3 is 12. 12 times 3 is 36. There it is. All right, 36 times 3 is 108. 108 times 3 is 324. And again, you can just get that with a calculator by typing. All right, so that means that f of x is equal to what? Let me look here. All right, so I need a, b to the x. That's what I need. So I need numbers for a and b. Now, b is the base multiplier. That's what I wrote right here. B is the base multiplier. So when you look, you say, okay, as I move down this table one by one by one, what happens? Times it by 3, times it by 3, times it by 3. That means that your base is 3. And a is your y-intercept. 0a is your y-intercept. So that means your y-intercept is 0, 4. So 4. There you go. All right, now let's look at g. Now g is going to be different because we're going to multiply, but we got to get smaller. We're not getting bigger like we were for f. So you try, in other words, you can think of it like division. So if you tried 400 divided by 2, that would be 200. 200 divided by 2 would be 100. 100 divided by 2 would be 50. So that'll work. That's perfect, actually. Okay, so 50 for that one. All right, so then what was this number up here? Well, it had to be 800, because if you multiply by, or excuse me, if you divide by 2 to work your way down the table, then you have to multiply by 2 to work your way back up. Okay, so that must be, okay, now remember, ab to the x. Now we need numbers for a and b and x. Well, a has to be 800 because that's what happens when it's your y-intercept. Your y-intercept is that a value. B is the tricky part because you're dividing by 2, right? 400 divided by 2 is 200. Divided by 2 is 100. But this isn't division here. This is multiplication. But remember, multiplication by a fraction is the same as division. So let's try it. 800 times a half. A half of 800 is 400. A half of 400 is 200. A half of 200 is 100, and so on. It works. All right. And h is actually the simplest one here because you can figure out real quickly what h must be. It must be, oh, sorry, that's an h. That's a typo. Make that h, so that way it's different than the others. Okay, so if that's h, then it's got to be ab to the x. But we're going to have to figure out what we're doing here. 27 divided by 3 gets you 9, right? So if 27 divided by 3 gets 9, then you have to times it by 3 to get that next number, right? So negative 27, oopsie, quit. Negative 27 times it by 3 gets negative 81. Times it by 3 again would get negative 243, and so on. So this is negative 81, this is negative 243, this is negative 729. There they are. All right, now again, that's where I got this from. When I look here, I think, okay, my a value is negative 729 because that's what happens when x is 0, period. Now the hard part is you're getting smaller, so you think, okay, if I'm getting down to numbers, that means I'm dividing. Division is the same thing as timesing by a fraction. So what you're multiplying by is a third. A third is the same thing as division by 3 because 3 is in the denominator. So there you go. All right, we're all done with that page. I'll meet you back here for talking about increasing and decreasing.